Here we have the equation 2x to the third minus x times y plus y squared equal to 12. And we want to find y prime or dy dx, which is the derivative of y with respect to x. And we will use what's called implicit differentiation to find the dy dx. So once more, this term does not have a y, and this term does not have a y. So we just do the regular derivative. So the derivative for 2x to the third, the reason we're doing regular derivative here is because we're doing derivative with respect to y. If we were doing derivative with respect, we were doing with derivative with respect to x. If we were doing derivative with respect to y, then it would have been different. But since we're doing derivative with respect to x, and the variable here is also x, so the regular or the usual derivative is 2 times the derivative of x to the third, which is 3x squared. And then minus, and then we'll leave space for the derivative of x times y, and then plus, and we leave some space for the derivative of y squared. And then on the other side, this is constant, and there's no y in here. So we just do the usual derivative. And derivative of constant is 0. Derivative for the y squared, we use the chain rule here. And so first do the regular derivative, which is 2 times y. And because we're doing derivative with respect to x, then we have to multiply the chain rule, is that using the chain rule, we have to multiply this by dy dx. And then right here, we have a product. And so we have to find the derivative of this product here with respect to x. Then we have to use the product rule. And the product rule is derivative of f of x times g of x is f of x times derivative of g plus f of x times derivative of g. And so right here, think of f of x as x and g of x as y. And so right here we'll get x, and then times the derivative of y, and then plus y times the derivative of x. And one more time, we want to find the derivative of y with respect to x. So the key word here is the phrase here is, the key phrase here is respect to x. And so here, this term, we just get x. And then times, and so right here, we're doing derivative with respect to x, but the variable here is y. And therefore, we'll do the regular derivative. The derivative of y is 1y. So this is the same as 1y, and this is the same as 1x. So derivative of 1y is 1, and then we have to use the chain rule on this part. So first do regular derivative, we get y. And then next we have to do times the derivative of the variable, which is dy dx. And then here we get y, and then times. This is the variable x, and we're doing derivative with respect to x, and therefore we just do regular derivative. And the derivative of 1x is just 1. And so this becomes x times dy dx and plus y. And so now come back over here, then that's what we put in here. So all of this becomes 6x squared minus, and notice that we have minus right here, so it becomes minus x dy dx, and then we have a minus here, and then we have a y in here, so that make it minus y, and then plus 2y, and then times dy dx. And remember that what we, after is this, we want to find dy dx. So we end up with 4 terms on the left side, 1, 2, 3, and 4. This term has dy dx, this term has dy dx. And since we're solving for dy dx, then what we need to do is move all of the terms that do not have dy dx to the right side. So we move this term right here from the left to the right, then because when we move a term from left to right, we do the opposite. So if it's 6x squared on the left side, when we move it to the right side, it's become minus 6x squared. It's the same thing as subtracting 6x squared from both sides. And this is minus y, so what we can do is add y to the left, add y to the right. And then here, the common factor is dy dx, so we'll put that in the front. So we factor out dy dx, then what's left is negative x plus 2y. And then on the right side we have negative 6x squared plus y. And then divide both sides by negative x plus 2y. And so dy dx is equal to this.